Good morning, folks. This is Mike coming at you with a continuation of our previous video. In the previous video, we began to talk about the properties of exponents, specifically power rules and product rules for exponents. So we will continue talking about them in this video. So we've dealt with multiplying exponential expressions by themselves and with other exponential expressions where the bases are the same. Now let's just talk about multiplying sort of basic terms. So what if our base is a product of two, could be more, terms, and we raise that whole product to some power? And what would it be if we had a quotient of two terms and we raise that quotient to a power? So a couple samples here. What if I had 3 times x and I raised that whole thing to the third power? Okay, well, let's just say what this is actually telling us. 3x raised to the third power is just saying 3x times 3x times 3x, all right? And we said from our previous video that we would multiply the coefficients and we'd multiply the variables. We know that the order in which we list terms when we multiply does not matter. So I can move the order that these terms are in so that I have all the 3's next to each other and I multiply them. And then I have all the x's next to each other and I multiply them. So that's 3 times 3 times 3 times x times x times x. And again, just using what the definition of an exponential expression is, this right here, 3 times 3 times 3, is saying 3 raised to the power of 3. And here, x times x is x raised to the power of 3. So looking at these two quantities, which we know are equal, it looks like we can just take the power and put that power to each piece of our product, each of the 3 and the x separately in this case. Or perhaps in terms you might be, that might be more friendly. It seems like we can just distribute that power into each term or into each piece of our product. Okay, well, we can see, as you look at the bottom of your screen, that this result does generally hold true. If a, b, and c are real numbers, a and or b could be variables, then the product of a and b, then taking that product and raise it to the power c, is equal to a to the power of c times b to the power of c. This also holds true if you have the product of 3 or more things as your base. That power will just get distributed to each piece of your product. Now, it's very, very, very important to keep in mind that it has to be a product. Has to be a product here. It has to be a product that you're raising to some power. It is not the case I can underline this as many times as I want, and I can say it as many times as I want. Somebody is still going to mess it up, but I'll still keep saying it, and I will still write it. It is absolutely not the case, or it's not always the case, that A plus B raised to the power of C equals A to the power of C plus B to the power of C. This is not the case. Do not think that. If there's a plus sign in the middle, you cannot use this property. You cannot just distribute that power to each term or to each piece. Cannot do that. If it's a product of things in your base, then yes, you can. Sum, no. Product, yes. Okay, what if we have a quotient? Say, what is x over 2? That whole thing raised to the fourth power. Okay, well, let's, again, just use the definition of an exponential expression. X over 2, that whole thing raised to the fourth power, is the same thing as x over 2 times x over 2 times x over 2 times x over 2. So we're just multiplying all these fractions. And we know that when we multiply fractions, we multiply the tops and we multiply the bottoms. So this is x times x times x times x. The bottom, 2 times 2 times 2 times 2. And then using the definition of an exponential expression with the top and bottom separately, well, this is x raised to the power of 4, and the bottom is 2 raised to the power of 4. So here it looks like, and we would think that we can just take our exponent and we can distribute it to each piece in our quotient. So the 4 becomes the exponent of the x, and 4 becomes the exponent of that 2. And that is also a result that generally holds true. If a, b, and c are real numbers, again, a or b could be variables, then the quotient of a and b, that quotient raised to some power c, is equal to a to the c over b to the c. Now for this particular one, b cannot be 0 because we would have 0 on the bottom and we cannot divide by 0. Similar to this rule here, it has to be a quotient. If we were taking the difference of a and b and we raise that entire difference to some power c, we cannot distribute the exponent to each term or each piece of the difference that we are taking. It is absolutely not generally the case that a minus b raised to the power c is equal to a to the power c minus b to the power c. Do not make this mistake. These are the two most common mistakes that people make when it comes to using their properties of exponents. They think that this is the case. You cannot say these. These two things do not hold always. All right? So don't think that way. If your base is a product or a quotient, you can distribute the power to each piece of your product or quotient. If your base is a difference or sum, then you cannot distribute the power to each term or piece of your difference or sum. It seems like I'm saying this ad nauseum. There is a reason I am saying it ad nauseum. Do not make these two common yet very critical mistakes. All right, so let's simplify each of these expressions here. We will do some of these here, and then some we will do together in class. Let's kick it off with the first one here, 3 times x times y, that whole thing cubed. Okay, so clearly this is our base, that's our exponent, and we see that inside of our base, we have these 3 things being multiplied. We have the 3, the x, and the y. We're multiplying each of these things. So we can use one of our previous properties that we talked about in this video. I can just distribute this exponent of 3 to each piece or each term making up this product. So this is the same thing as 3 cubed times x cubed times y cubed, or raised to the 3rd power. Cubed, saying the same thing as raised to the 3rd power. Okay, so 3 cubed, 3 times 3 times 3 is 27. And then we have x cubed, and then y cubed. We'll do this one here. We'll go through this one in class. Okay, this one, again, something very common that you are going to see in this course and in higher level courses as well. We have a number being multiplied by an exponential expression. Again, we have to deal with the exponential expression first. That comes from our basic order of operations. So I look at my base here. I see that it is indeed a product of things, not a difference or sum. So I can use the property that we just used for this problem here. This is going to be the same thing as 3 to the power of 2 times z to the power of 2. This 2 goes to the 3 and to the z only. It does not go to the -7 because the -7 is not inside of these parentheses. Okay, so I have -7 times 3 to the power of 2 is 9. And then we just have z squared. And now I can multiply these two numbers. -7 times 9 is obviously -63. And then we had z squared. So as I said, try this one on your own. We will kick it off with this one here, x divided by y, and that whole thing raised to the 5th power. Again, our base is a quotient this time. It's not a difference or sum. So we can use one of our properties, and I can just distribute this 5 as a power for the x and a power for the y. So this is the same thing as x to the 5th power divided by y to the 5th power. I'll let you do this one on your own. Should not have any troubles with that if you understand this first one that we just did here. And we'll go to this one here now. 3x divided by 7. And that whole thing being raised to the power of 2. This one is a little bit more complicated. It's a little bit more involved. But starting off, again, we see that this is a quotient, not a product, or not a difference or sum. So we can use our properties that we have talked about in this video. So this is going to be the same thing as taking the exponent of 2 and applying it to the entire numerator and the entire denominator. So it's the quantity 3x raised to the power of 2 divided by 7 raised to the power of 2. Okay, well, we know what the bottom is. 7 to the power of 2 is 49. That top now, we have a product of two things. We have a product of two things being raised to some power. So we're going to use the property of exponents that we used for these two problems here. And I'm going to make this 2 the exponent of the 3 and the x, and then take those products. So this is going to give me 3 squared, which is 9, times x squared. And there we have it. 9 times x squared divided by 49. So try this guy on your own, and we'll go through it in class. Guys, this concludes our video finishing up section 4.1. In the next video, we are going to talk about some more properties of exponents, specifically the quotient rule. If you have questions or comments, be sure to reach out to me, guys. Emails, in-person office visits, phone calls, telegrams, messages by carrier pigeon, whatever you have to do. Until the next video, take it easy, guys.